Let's now look at the progressive wave equation. Now, we've already looked at what the graph looks like. Now, we can see that there's a new arrow over here that we are representing with P. Now, what is this P? Now, if the wave moves from, let's say, the left to right, so we are moving from our left to our right. So if the wave moves from left to right, the particle at O is first before the particle at P over here. So if the wave is being generated, we can say that the particle at O over here will be displaced first before any other particle at P will then be displaced later on. So if that happens, we therefore say that what the particle at O lead the particle at P. So we say the particle at O, okay, lead, okay, the particle at P, or we can say the particle at P lag on O. Okay, so this is one. This is particle at P lag on what? The particle at O. Okay, so the fact that the particle at P lag on particle of O, or the particle of O lead the particle at P, is by a phase angle, and that phase angle is what we have over here. Okay, so we represent that with this, and this is what we call our phase angle. Now the phase angle is given mathematically as what? 2 pi x over lambda. Okay, so this is the phase angle. So if the displacement of O, which we said will occur before the displacement of the particle at P, we therefore say what? That the particle at P lags on particle at O by the phase angle, or the particle at O lead the particle at P by this phase angle. Now, the displacement of the particle at O, over here is given by the wave equation y is equal to what? A sine angular velocity multiplied by time. Okay, so this is the general equation for the particle at O. Now, if the displacement of the particle at P, which lags on O, if you want to write the displacement of the particle at P, which lags on O, we write that as what? Y is equal to what? A sine, then into bracket angular velocity minus what? The phase angle that we are talking about. Because already we said the particle at O will move before the particle at P. So it therefore means we need to subtract something, or we need to subtract the phase angle from the displacement equation of the particle at O for us to be able to get the displacement equation of the particle at P. Now, the angular velocity over here is given by what? 2 pi v on what? On lambda. So if we do the substitution of the angular velocity over here, and then the phase angle over here, we now have a new equation that looks like this. So let me use this blue. So we now have a new equation that looks like this. So if we do the substitution for this equation, we now have y is equal to a sine, then into bracket, we said the angular velocity is what? 2 pi v over lambda, then multiplied by the time, minus the phase angle, which we said is what? 2 pi x over what? Over lambda. Alright, but we know that our velocity is equal to what? F lambda. So it means if we make frequency the subject, okay, if we make frequency the subject over here, we are going to get frequency is equal to what? Velocity over what? Lambda. So which means this part of the equation, let me use this color. The velocity with respect to the lambda over here, in place of everything over here, we can represent that by what? The function f, or the frequency. So if we do that, the whole equation becomes what? Y is equal to what? A sine into bracket 2 pi f t minus what? 2 pi x over what? Over lambda. So this equation is what we call the progressive wave equation, okay, where the y over here, okay, is the displacement of any particle from the origin. Now the x over here is the distance of the particle from the origin. So as we can see, if this is the origin, this is the s that we are talking about. So it's the distance of the particle from the origin. Now the v that we have, okay, from this side is the velocity of the wave, we know. The a over here is the amplitude of the wave. The f over here is the frequency of the vibrating particle, and then the pi is definitely a constant, and then the t is the period of the wave. All right, so now that we are done with this, let's move on. But before we go on, we can see that in this diagram we said what? The wave was moving from what? The left to the right, okay, and that is how come we are subtracting the phase angle from that of the general wave from the origin. But what if we have the wave moving from the right, okay, to the left? Okay, so if that happens, the only thing that changes in this progressive wave equation is that we have the equation, instead of having negative over here, it becomes what? Positive, because we need to add the phase angle. So we have from left to right, okay, or that is in the opposite direction, we have the equation y is equal to a sine into brackets 2 pi ft plus what? 2 pi x on what? Lambda, or wavelength. All right, so with this being the case, let's have a look at an example. So we have a wave profile is represented by y is equal to what? A sine into brackets 2000 pi t minus pi x on what? 17. We had to calculate for each I wavelength, II velocity, III frequency, and IV the period. So let's go ahead and look at how we solve a problem like this. So we have, first of all, we start by, let's write the general wave equation. So the general wave equation we know is y is equal to what? A sine into bracket 2 pi ft minus what? 2 pi x on what? All on this is just one, all on wavelength, or lambda. All right, so if we rewrite the general wave equation that we have been given in the question, we have y is equal to what? A sine into bracket 2000 pi t minus what? Pi x over what? 17. All right, so it means if we compare these two equations, we can see that we have a sine here, a sine over here. Now if we look at this part and this part, we can see that there's a difference, okay, so we can equate these two sides of the general wave equation. So we have what? 2 pi ft should be equal to what? 2000 pi t. Okay, so from here we can cancel out the pi's that we have. We can cancel the pi with this, we can cancel the time with this. So from here we have 2 multiplied by the frequency is equal to what? Just 2000. So we divide both sides by 2, we get our frequency to be what? 1000 hertz. Okay, so straight away from here we know our frequency is going to be what? 1000 hertz. Now we've been asked to find the period. We have the period in the question, but we know period, okay, period is what? 1 over period, which is t, is equal to 1 over frequency. Now we already calculated for the frequency, so it means 1 over what? 1000, okay, is going to give us our period, okay, and that is equal to what? 1 times 10 raised to the power negative 3 seconds. All right, now let's move on. If we look at this, we also need to find wavelength and the velocity. So what do? Let's equate these two equations again. So we have 2 pi ft is equal to what? This 2000 pi t over here. Now remember we did some substitution where we substituted frequency in place of velocity and wavelength. Okay, so we said what velocity is equal to what? F lambda. Okay, and if we make frequency the subject over here, we get what? Velocity on wavelength. So it means in place of frequency over here, we can substitute this over here. So we have 2 pi v on lambda t, okay, is equal to what? 2000 pi t. Okay, so it means the pi can cancel the pi, the time can cancel the time over here. So we have 2v on pi is equal to what? 2000. Okay, so let's make this equation 1. All right, let's have a look at another aspect. If we look at this side and this side, we can see there is a difference, so we can equate those two. So we have 2 pi x on lambda is equal to what? Pi x on what? 17. So if we cancel out these two over here, we're going to have 2 multiplied by 17, that is going to give me 34, is equal to lambda multiplied by, here will become 1, it becomes what? Lambda. So it means our wavelength is what? 34. So it means lambda is equal to what? 34 meters. Okay, but now that we have lambda, we have frequency, we can now calculate for our velocity. Okay, we know velocity is equal to what? F lambda. Okay, so from here we know that our velocity, okay, from here we know our velocity will be equal to the lambda, the frequency, which is 1000. So we have 1000 here multiplied by the lambda, which is 34. So we have the velocity to be what? 34,000 meters per second. Or from the equation 1 that we have over here, it means 2v is 2v over the lambda, which is 34, is equal to what? 2000. Okay, so if we cross multiply, we have 2v is equal to what? 34 multiplied by what? 2000. Okay, so if we divide both sides by 2, we get to write 2 go here 1, it will go here 1000. If we use the 1000 to multiply the 34, we get our velocity to be what? 34,000 meters per second. So therefore we can conclude that our wavelength, okay, is what? 34 meters. Our velocity is what? 34,000 meters per second. Our frequency, our frequency is what? 1000 hertz. And IV, our period is what? Times 10 raised to the power -3 seconds. So this is the answer for this example. So let's go ahead. So example number 2, we have a plane progressive wave is represented by y is equal to what? Y is equal to 0.1 sine 200 pi t minus what? Minus 20 pi x on 17, where y is the displacement in millimeters, t is time in second, s is the distance from a fixed origin, o in meters. So we have to calculate for the frequency of the wave, the wavelength, the speed, the period, then the phase difference in radians between the point 0.25 meters from O and the point 1.10 meters from O. So let's have a look at the solution. So as usual, the first thing we do is what? We write the progressive wave equation because we need to compare. So we have y is equal to a sine into bracket 2 pi ft minus what? 2 pi x on what? On lambda. But the equation we've been given in the question is what? A is equal to what? 0.1 sine into bracket 200 pi t minus what? 20 pi x on what? 17. Alright, so the first question is telling us to find frequency. So for frequency, we know we have frequency over here, we don't have f over here, so we can equate these two. So we have 2 pi ft is equal to what? 200 pi t. So the pi t will cancel out, so we have 2f is equal to what? 200. So it means our frequency is equal to what? 100 hertz. Straight away from there, we know our frequency it's 100 hertz. So let's look at the II. So we are to calculate the wavelength. Okay, so the wavelength over there. So calculate the wavelength. That is the second aspect. So the wavelength, we can see wavelength over here. So we can compare these two. So we have 2 pi x on lambda should be equal to what? 20 pi x on what? On 17. So the pi x can cancel each other out. So it means we have the 2 here will now multiply the 17, which will now give me 34 to be equal to the wavelength over here will multiply the 20, and that gives me what? 20 pi. So we divide 20 lambda. So we divide both sides by 20. We get our lambda to be equal to what? 1.7 meters if we divide 34 by 20. Now the next thing we want to look at is the speed, the speed or the velocity. So we know velocity is what? F lambda. So straight away we know we've already find our frequency, we have our lambda or the wavelength, so we can find velocity easily just by multiplying what? 100 by 1.7. So if we do that, multiply 100 by 1.7, we are going to get what? 170 meters per second. Okay, right, let's look at IV. So IV, we have to find the period. As easy as ABC, we know period or the time is equal to what? 1 over frequency. So it means our period is what? 1 over the frequency is what? 100. So it means our period over here, our period is equal to what? 0.01 second. Alright, now the last aspect of the question is telling us to find the phase difference in radiance between a point 0.2 meters from the origin and a point 1.1 meter from the origin. Now like I said earlier on, that is this is IV. Like I said, phase angle is equal to what? 2 pi x over what? Over lambda. Now we have our lambda, which is 1.7. We know pi is a constant. We have to find the phase angle. So the only thing left is what? The x over here, which is what? The distance. Now we have to find it between two distances. So if we subtract the highest from the lowest, if we subtract the lowest from the highest of these 2 points, we get the value of x, and then we can substitute that, and then we find our phase angle. So if we do the subtraction, it means our x will be equal to what? The highest over here is 1.1 meters. Then we subtract the 0.25 meters from that, we get our x to be equal to what? 0.85 meters. So now that we have the value of x, it means our phase angle is equal to what? 2 pi into bracket 0.85 on what? Our lambda, which is what? 1.7. Our phase angle is equal to, if we multiply 2 by 0.85, we are going to get 1.7 pi over what? 1.7. So this cancel out, so it means our phase angle is equal to what? Pi radians as our answer for this question. So our frequency is 100 hertz, our wavelength is 1.7 meters, our velocity is 170 meters per second, our period is 0.01 second, and then our phase angle between these 2 points, that's 0.25 meters from the origin and 1.10 from the origin, is what? Pi radians. Now let's have a look at one final example. Alright, so a progressive wave is represented by the equation y is equal to 10 sine 4 pi into bracket 15t plus what? X. So we have to calculate the amplitude, the wavelength, the velocity, and the frequency. So as easy as a piece of cake. So let's let's write down the solution. So we have the equation, the progressive wave equation. We know is a sine into bracket 2 pi ft minus 2 pi x on what? On lambda. So the one we are given is what? Y is equal to what? 10 sine into 10 sine. Let me erase this. Ten sine 4 pi into bracket 15t plus what? X. Now if we look at this, we get to realize this is not exactly in the form as the general progressive wave equation, because we have the pi outside, so we need to expand this. So if we do the expansion, we are going to get 10 sine, then we multiply 4 pi by this, we are going to get what? 4 multiplied by 15, that is going to give us 60 pi t. Okay, so we have 60 pi t plus 4 multiplied by this, we are going to have what? 4 pi x. So this now becomes what? Our equation. That is if we expand what we have over here. So straight away, let's look at what the amplitude is. So if we compare this equation, let's say equation 1 and equation 2. If we compare these two equations, the amplitude is the A over here. So if we compare the two, the A is equal to what? 10 meters straight away. Now the II, we have to find what? The wavelength, which is what? Lambda. Okay. If we look at the two equations, we have wavelength over here. So we compare these two sides of the equation. This is plus, so it means this also has to be plus, because that means the wave is moving from what? The right to the left. So if we compare these two guys, we have 2 pi x on lambda to be equal to what? 4 pi x. Okay, so this should be over 1. So these two guys will cancel these two guys. So we have this will not multiply this, so we have 4 pi is equal to 4 lambda. 4 lambda is equal to the 2 multiplied the 1 is equal to 2. So we divide both sides by 4. We have our wavelength to be what? 0.5 meters. Alright, so now that we are done with that, we now have to find what? Velocity. So I velocity. Now we can see that before we are, velocity is what? F lambda. Okay, before we find the velocity, we need to find the frequency, because we don't know the frequency, and we can find the frequency from here. So if we compare, let's jump to IV first. So if we compare, we have what? 60 pi t here should be equal to what? 2 pi f t over here. So the pi t's will cancel out, so we have 60 to be equal to what? 2f. We divide both sides by 2, we get our frequency to be what? 30 hertz. And now that we have the frequency to be 30, it just means that our velocity now is now 30 multiplied by what? 0.5, and that will give us what? 15 meters per second as our velocity. So thank you guys so much for watching, and I will see you in the next video. Bye bye.